Hello all. In the last session we have seen two important word-to-vector models which were CBOW and skipgram, right? So today in this session I would like to cover GLOW and FASTECT, other word embedding models, along with how do we perform document level embeddings, and we'll also see visualizing the embeddings, okay? So when we have talked about CBOW and FASTECT, they are two important word to vector word embedding models. Apart from that, we also have another popular embedding model which is called as GLOW, which is named after global vectors. Okay, so GLOW is nothing but one important pre-trained word embeddings model which is widely used in NLP applications today. So before we actually go into GLOW, we will have a quick recap on CBOW and skipgram models. Okay, so skipgram uses a prediction task where the context word is predicted from the target word, right? So we have seen in skipgram model the context word will be predicted from the target word, and the vice versa was for CBOW model. Okay, now in case of skipgram, the process will be repeated many times as there are word tokens in the data set. Okay, basically what skipgram does is it scans the entire data set and asks the question, can this word be predicted from this other word? Okay, for every single occurrence of the word, even if you have 10 words, for each and every word the same question will be asked if this word is in occurrence in the data set. Okay, that is one limitation that we consider in the skipgram model. Okay, if suppose we have two or more identical sentences or similar sentences also, okay, what will happen? Skipgram would repeat the exact same thing again and again, that is multiple times it repeats the same things. For example, if suppose I have, can bark be predicted from dog? We might ask, can bark be predicted from dog? But chances are already this question might be repeated n number of times in the data set, that is we are simply adding x with 1 plus 1 plus 1 plus 1 plus 1. If it is repeated n times, we are adding each and every repetition to the existing data set instead of just taking x plus n. Okay, so this is one limitation in skipgram model, that is occurrence of the words are not occurrence of the word. If it is repeated multiple times, the multiple times it is considered. Okay, now therefore, in order to overcome this particular disadvantage of skipgram or CBOW model, we will go for GLOW model. Okay. Now, how GLOW model learns word embeddings? Okay. Now, when we talk about GLOW, we talk about global information. Okay. So, basically the design of GLOW is motivated by taking into the drawbacks of skipgram and CBOW model. Okay, herein instead of using local word occurrences, please remember this word, instead of using local word occurrences, GLOW model uses aggregated word co-occurrence. Okay, so the statistics in the entire data set would be analyzed and only the repeated words would be referred to as n times. Instead of adding them to each and everything, it would be repeated as n times. Okay, so in some cases where suppose let's use the word dog and doggy. Okay, so if you have these kind of notations, sometimes though dog and doggy are related, sometimes they may be considered as different word, but most of the cases the repetition would be represented in your GLOW word embeddings. Okay, so when we talk about this, basically token is a occurrence of a word in the text. When we talk about co-occurrences, token is nothing but the occurrence of word in a text. Okay, so if you have multiple occurrences of the same word in the corpus, okay, we will consider only one word. For example, look into this sentence, a rose is a rose is a rose. Okay, this is a sentence. So I have rose repeated 3 times here. Okay, there are 8 tokens but only 3 types. What are those 3 types? A is a type, rose is a type, is a type. Okay, so when you talk about occurrences, we consider the type. Okay, so a rose is a rose is a rose, in which I have only, though there are 8 tokens in this, I have only 3 types. A is one word, is one word, rose is the third word. So glove takes into consideration the types wherein the repeated occurrences would be eliminated. Okay, now when we talk about glove model, we also have few pre-trained glove vectors. Okay, so we know the importance of pre-trained data, right? So instead of developing the model from the scratch, we just use the features of the pre-trained model into the new model, right? So glove has pre-trained vectors also. So your glove model can be used along with the pre-trained models. Okay, so instead of downloading and using the word embeddings, we use pre-trained models from this large corpora which is available. Okay, so by using this will benefit us in developing many NLP applications which can be accurate, because the pre-trained word embeddings are usually trained on larger data sets which have more computational power than what we can afford. Okay, apart from that, when we use pre-trained word embeddings, okay, you can stand on the shoulders of giant. That is, you can leverage high quality linguistic knowledge from the existing corpora. Okay, so if you want to learn more about glove, you can visit the Stanford. Glove is developed by Stanford University. So you can go to this particular URL and check about different features which are available for your glove word to vector model. Okay, now after word to vector, after glove word embeddings, we have the next model which is called as fast text. Okay, now how do we train word embeddings using our own text data is the question. If suppose I am not interested in the pre-trained data, if I have own text data, how do I train that? So the answer is fast text. Okay, so fast text is a popular word embedding toolkit. Okay, so this is the most basic and most commonly and popularly used for textual data. May not be in general domain, but yeah, so we use this fast text. Okay, now making use of subword information is very important thing which is considered in fast text model. Okay, so what is the importance of fast text is, the fast text model actually considers the use of distinct word vectors for each word. As I told you in the previous case, when we have two words called dog and doggy, that is only one word, but you have two distinct word vectors for the same word which is dog and doggy, because here y is an English suffix that denotes some familiarity or affection to the word dog. Similarly, when you talk about grandma, granny, kitten, kitty. Okay, so these are some pairs of words which have semantic connection. Okay, so in case of this particular wordings, okay, fast text would help us. Okay, so that granny, gran, all that things are limitations to the existing models which can be overcome by this model which is your fast text. Okay, so basically fast text is an algorithm and a word embedding library developed by Facebook. Okay, so glove was developed in Stanford University, whereas fast text was developed by Facebook. It basically uses subword information, which means information about linguistic units, to train high quality of word embeddings. Okay, basically fast text breaks down the given word into some engrams and start learning the embeddings for them, like dog, doggy, kitten, kitty, kitten, grandma, granny, and all that stuff. Okay, so this is an example simple architecture of the fast text model. So we take the words along with their engrams. So what are engrams? So engrams are nothing but the different notations I get from each word, right? Apple, apples. When you talk about apples, there are two engrams in this, apple and es, apples. Okay, so your fast text model consider characters and engram embeddings. They are given to linear layer from which your predictions will be done. Okay, now There is another benefit of fast text model, not just considering the distinct words from the given word embedding, but also out of vocabulary words. Okay, so we have this terminology often used in the context of NLP, which is out of vocabulary problem. Okay, so when I talk about out of vocabulary, okay, sometimes I may scan a textbook from 1980s, okay, and I may search for some other word in the latest context, that is Instagram or Facebook, which may not be available in that particular textbook which I used earlier. So those words are considered as out of vocabulary context. Okay, so many NLP applications and models assume fixed vocabulary, that is a typical word embedding algorithm will be used, whereas you can use skipgram, cbow, glow or fastect. Okay, so the training data may be trained on that particular thing, but when it comes to test data, we may give the words which are not available in the training data. So such words are called as OOV words, out of vocabulary words. So when you have this OOV words, the result or your test data may fail. Okay, so for example, if you train scriptgram word embeddings on book published in 1980s and apply the same book onto the social media text where you find the word Instagram, okay, so you may not find it. So in that context also, this fast text algorithm helps because it uses subword information. So Instagram would be divided into Insta and gram. Okay, instantly. Okay, so subwords along with their engrams can be used such that we can avoid the problem of OOV. Okay, so FastTech toolkit. So you can go to this website realworldnlpbook.com and it's in .html. You can find the details about the fast text model. Okay, so this is an open source library provided by Facebook. Okay, next we'll talk about document level embeddings. So far we have looked into word embeddings, right? We have seen what are word embeddings, what is the need for word embeddings and all that, right? So we've also seen Glow, fast text models, cbow, skipgram models, which helps us to identify or work with word embeddings. After word embeddings, the next level in NLP is document level embeddings. Okay, so if we are working more on NLP tasks, we will be concerned with larger linguistic structures. Okay, so we have started with word, but using words we form sentences, and using sentences we may prepare documents, right? So when you take the entire document into picture, then we consider document level embeddings. So for attaining this document level embeddings, so to work on document level embeddings, we have many traditional machine learning tools like logistic regression, SVMs, along with word embedding models, we can work on with document level embeddings. Okay, now there are two things that comes into picture when we talk about document level embeddings. The first question is, how can you represent larger linguistic units such as sentences using vector? Right? So word embeddings, it wasn't a problem because each word is represented as a vector. But when you talk about document level embedding, how do you represent one sentence as a vector is one question. And the second question is, how can you use word embeddings for sentiment analysis? When I talk about sentiment analysis, do I have to use word embeddings or do I have to use sentence or document level embeddings for sentiment analysis? Okay, when these two things come into picture, the one way to achieve this is simply to use average of all the word vectors in the sentence. So first we go for word vectors and then we go for average of word vectors in the sentence. Okay, so you can take the average by taking the average of first element, second elements and so on until a new vector is combined by average numbers. Okay, after that we can use this new vector which is the average for giving it as input to the machine learning models. Okay, so although this is very simple, it has one limit. Okay, for example, when I talk about these two sentences, Mary loves John, John loves Mary. Okay, both of them have three words, right? So when you do the average, it would be same. but John loves Mary is a different sentence, Mary loves John is a different sentence. But when you talk about the context, this sentence has the same 3 words, the other sentence also has the same 3 words, but the meaning, John is loving Mary here, Mary is loving John there. The meaning of the sentences are different, but when you are doing the averaging or when you are taking the words into picture, this fails. Okay, so we cannot go with this particular method, that is averaging will not work. Okay, so in order to overcome this disadvantage of averaging and all that stuff which will not work, many NLP researchers have worked on many algorithms. Okay, and the popular algorithm is doc to vector. Word to vector was the previous one, here it is document to vector conversion. Okay, and then this model, as the name suggests, learns vector representation for documents. Here document will be the input. Along with document, we also have other algorithms which were developed by so many other researchers, like sentence to vector, paragraph to vector and all that stuff, but we are not going in depth about all this. We will be just looking into word to vector representations. Okay. Okay, so this is an example of document to vector, where we take paragraph embedding, paragraph ID along with the sentence that we give, we join. The reason why we are using join is, in a paragraph or in a document we may have multiple sentences. So I take one paragraph with one sentence and then join all the sentences, that would give me the entire paragraph as input to the linear layer, from which I will generate the scores. Okay, and then finally visualizing embeddings. How do we visualize embeddings? Okay, so retrieving similar words from a given query is a great way to quickly check if the word embeddings are trained correctly or not. So generally we have learned that word embeddings are simply n-dimensional vectors. We have seen how do we point in n-dimensional space. We use 3D vector here where n is 3. Okay, so we represent this word vectors in 3-dimensional space. Okay, so if you want to if you have more number of words, then putting more number of words in the 3D space would be clumsy, right? So in order to overcome that disadvantage, we have so many other this disadvantage is called as dimensionality reduction. This problem is called as dimensionality reduction problem. Okay, so in order to overcome that, we use principal component analysis like what we have done in machine learning. We also use ICA, independent component analysis. Apart from this, for in the context of NLP, when we talk about word embedding visualization, this is one of the important technique which is called as TSNE. Okay, it is pronounced as TSNE, T distributed stochastic neighbor embedding. Okay, so using TSNE, we start visualizing the word embeddings. Okay, so this is the conclusion or the summary. We have seen word embeddings are numerical representation of words that helps us to convert discrete units into some vectors, and then we have seen 2 models, skip graph and Seabow model. Along with these 2 models, we have we have also looked into advanced word to vector models, GLOW, which makes uses of global statistics to avoid the co-occurrence of the words, and we have also seen fast text and doc to vector for global document level embeddings, and then we have also seen for visualizing word embeddings we will be using TSNE. Okay, so with this we are done with word embeddings, document embeddings, and how do we perform visualization for the embeddings. Thank you.